Hello, everyone. Today we are going to see the data collection with TI's AWR 2243 automotive radar. Now let's get started. We are gonna do a short demo. Now, I would highly recommend you to look into this link uh, for the for this video about this 8000 training. It shows you all the connections that you need to make and how you should kind of like set up your drivers and your IP address. And I'll show you them as well. Now I'll kind of like show you the radar connection. I don't know if it's visible from the camera. Okay, now we have one Ethernet port in the back. This one is connected to DCA, and there's only one Ethernet port, so you cannot do it wrong. Uh, on DCA there are huh? Oh, okay, yeah, okay, yeah, okay, it's easy. Now, the Ethernet port is here, as you can see in DCA. You cannot plug in this one. For the USB, so there are two USB cables. One of them is connected to DCA, and other one is connected to the radar in the front. It's red board. The green one is the DCA board, and you need to connect this USB cable to the top port. In the down, in the bottom part, there's another USB port here, USB-B, but you are not going to use this. You are going to use the top one, this one. Okay. So these are the connections, and the other ends of the cables are going to go into your laptop. The other USB cable is connected to radar. There's only one port that can go into radar, so you cannot do this one. Other end of this cable is regular USB port, and next we have this power adapter. So this power adapter should be 5 volts and 3 amperes. So some of the adapters in the lab, they have 12 volts. So you should be careful while kind of like plugging in this radar's adapter, because we tried one with one of my with former lab mate Mahmoud. You can see. So what you need to be careful about the power of the adapter. It should be a 5 volt. Okay. So now, once you plug in all the cables, you should see this uh, green light should be on, the one in the corner, and the one here also is on. So if you see any red lights here, it means there's an error with your setup. So you can try to restart your radar by powering it off and on. Now these switches are also important here. So the order should be like this: two up, two down, two up, one down, one up, depending on in what configuration you are using the radar. If you are doing some like software development for the radar, then you may want to change the switches as well. So next other thing, uh, important thing on the hardware are these switches. These There are three switches in the bottom. SAP SOP 0, 1, and 2 from top to bottom. 0, 1, 2. This 0 and 1 should be connected to for you to be able to collect data with MMH Studio. So make sure these are connected. And so these jumper cables should be on. Yeah, that's the thing. In the very bottom one, you see there's no jumper. It's kind of not connected. So now our radar is all set. Also, sometimes be careful this small SD cards in the top. When you press it, it kind of jumps up. Sometimes it's being jumped up, so it may not collect data when it's kind of up. So you need to make sure that it's pushed in. Okay. So now it looks like we are all set. So also for one last thing, if you need to have separate powers for DCA and radar for some reason, you need to change the switch to left. here. Otherwise, if you keep it on the right, according to video, you can get the power for DCA from the radar. So you can use only one adapter. Otherwise, you have to use separate two adapters for your setup. So now our radar is all set. So on the computer side, what we need to do, we first need to make sure that we install MM-based studio. In our previous video, we have seen how we need to how that is yeah this MM-based studios. Okay, okay, this is MM-based studios user guide. Make sure that you understand this thoroughly, and here you can look into how you should kind of like capture data, how you should install. So basically, there are certain steps that you need to follow. You need to install the drivers and change the IP address. And once you install the drivers in your device manager, if you look at the device manager, your ports should look like this. So you see, it's the same as here. So this do one that says class application user UART, the ones that says UART, this COM port number is important. This is something that we are going to use in our MMA Studio configuration. Okay, here it's like COM port 7. And the next important thing is the IP address. So you need to change the IP address of your Ethernet. Now, if I open the network and sharing center, you go to change adapter settings here, and then you find your Ethernet cable here, and then you open it up. You go to properties, and under properties, at Internet Protocol version 4, you need to click it, and you need to use you need to change this IP address 192.168.33.30. So this should be your IP address, and then you say OK, and then OK, and you can close. Now I'll restart the MM Studio. So you shouldn't be getting any error while MMA Studio is opening. Your MATLAB runtime engine also should be installed. You can find this, you can find the link to download this in MMA Studio's user site. So it says script completed successfully. So in this MMA Studio, this bottom left part should be green when a script is done. So MMA Studio is in the background running some Lua scripts that I'll show you in a bit. And outputs of those scripts are kind of being shown here. Okay. If you do not see this output window, then you can just go to view and then output. Just click on this and then you should be able to see. If you want, you can also show a Lua shell so that you can write some Lua shell commands. And MMS2 also has property to kind of like integrated with MATLAB. You can also send these Lua commands from MATLAB as well. But we are not going to go into this one now. So now, when we open up the MMS Studio, the screen that we see is going to look something like this. So first thing we need to do is to reset the radar. So we just click on this button. Okay. Next, we need to set our communication port and baud rate and connect radar. But communication port here is not correct. As you can, it says COM3, but it should be 7. So you change it to 7. If you choose this wrong, you are gonna get error here. So also you need to, like, when you first open up the Studio, you need to see that number of devices that detected should be 1, and this FTDI should be connected. If you do not see it, just try to refresh it. If it doesn't come after refreshing, that means something is wrong with your connections. Okay. So now we set this communication port and baud rate, and we click on connect. baud rate should be 115 and 115,200. If sometimes it's being 96,000, you need to change it if that's the case. So now we need to run this meta image of radar firmware, but we are not going to do this manually. What we need to do, in the bottom you see this long path. So these are the paths that you want to run on the right side of the screen, okay? And we are going to find the right script to do our demo, okay? Now you should be able to see your device correctly, 224377 gigahertz. Now we are going to browse. So where our scripts are located, if I go to the Windows C, okay. So if you choose the default installation path while installing MMI Studio, it should go, it should create a folder named TI under local disk C. You go into C, and depending on which MMI Studio version you have, you need to go into that one. So for this radar, we use 3, because for the second generation radars, we use MMI Studio 3. But if you are using first generation radar, for example, something like xWRxxx, if you are using that one, then you need to use MMI Studio version 2 or 1, either of them. Okay. Now you go into MMI Studio 3, and then MMI Studio, and then scripts. Here you will find a script named data capture demo underscore xWRLua. Okay, this is the demo script that you want to use for data capture. Okay, you need to open this up. Okay, now our path is changed. Now we are going to run the script. So it's running. Let's wait for it. Okay, make sure that you are not getting any errors here. Now it's kind of sent a sample frame and then ended it. Now it's kind of post-processed it, and it's showing us the output from the radar. So you can inspect different things here, 1D FFT, 2D FFT, whatever it is. But we are not interested in this. So we are just going to close this. Yeah, it collected very small amount of data for one of it. So now, what we want to do, we want to use our own radar configuration, radar parameters, okay? So now, these tabs in the second row, static config, data config, test rows, sensor config, these are all the parameters that you can play it with your radar. So it's like really configurable. So I'm not going to do all of them one by one, but I'm going to import a configuration that I saved previously. So there is a button here, load configuration. Also, if you make your own configuration and save it, you can just use this save config file, and it kind of exports your configuration as an XML file. Okay. Now I'll kind of load the configuration file I have. Let me try where it was. Yeah, BPM ASL. So this is the one that I was using. So let me open it up. So I opened it up, but it's not setting everything. So you need to make sure that you are setting everything as well. So this one is going to be using TX0 and 2. So TX0 and 2 are the left and right, very left and very left antennas. So if it's not using elevation, But if you want to use elevation, for example, in this case, let's say we want to use elevation, we enable this TX1 as well. And cascading mode, we don't have cascade. Cascade radar is different, so this single chip. And we click on set, and then click on set here, and then we press on RF unit. And now this tab is done. Next we have data config. So by the way, you need to do these clickings in order. The order is being shown with the blue text color. I hope you can see them here. So we click on set. Now the blue one is here, this one, and then this. Yeah, it will guide you automatically. And then test source is not something we are interested. You can just skip. Sensor config is the most important part. This is the part that we have seen in our previous lecture, where we are kind of like defining our chirp profile. Okay. So you can see here the start center frequency 77 GHz. Your slope is 80 megahertz divided by microsecond, and your idle time is 100 microsecond. Your number of ADC samples 456, and your bandwidth becomes 4 gigahertz. So it's being calculated automatically. So for example, if you change the slope to 70, it's going to change as well. See if it got down. So we just keep set 80, and then we click on set. So this profile window is set right now. So again, we are doing things in order. So now we need to define our chirps in this window. Okay, this is also a very important part. So now let's say you do not want any angle information. You are not going to use any angle information in your setup. Okay, so in that case, using one antenna is one chirp is enough. Okay, you can use only one chirp. So here the profile ID is the profile ID that you define here. So we use ID of 0. So we need to use this ID. Okay, this is 0. So this will be consistent. You can also define multiple profiles as well. You can define for 0, 1. And let's say for the other profile, you want to have profile ID of 1, and then you change your other parameters, etc. You click on set. So those profiles are also being saved in the background. Okay. And let's say we have our profiles, and then we want to use profile 0. Okay. Now we are also choosing which chirps we want to manipulate. Okay, we want to define. So in this case, since I have only one chirp, I'm just gonna say chirps from 0 to 0, because there's only one chirp, it's chirp 0. Okay, and this chirp, you can either use only one transmitter, or you can activate all of them, or you can activate two of them. It doesn't really matter, because you are kind of using one channel at the end. Okay, they are all going to be saved in the same place. So if you want to increase your kind of like receive power, you can use all three and click on set. Okay, so now your chirp is defined in the presentation. So this is your chirp 0. You define your chirp profile. Okay, and then you define your chirp 0 as well. But you don't have chirp 1. Okay, you only have one chirp 0. So now we need to define our chirp loops. So start chirp index and then end chirp index. So since we have only one chirp, I'm gonna say 0 to 0. So our chirp loop is going to have only one chirp. Okay. So a number of chirp loops in a frame. I can set this to 255. Okay. Because I have only one chirp, and I can transmit 255 chirps. And here is our duty cycle. Duty cycle is the kind of ratio between your full time interval. Let me show it here. The duty cycle is this: like you have your frame period, and the interval that you have filled up with your chirps is the kind of utilized time, and this interframe time is the empty part. So your duty cycle is depending on the ratio between this active time and interframe time. Okay. So now our periodicity is 40 milliseconds, which corresponds to 25 frames per second. So because when you divide 1 by 40 milliseconds, you get 25. So you will have 25 frames in a second. Okay, this number of frames is the uh, how many frames you want to transmit. If you transmit 250 frames, it means that we are recording data for 10 seconds. Okay, because yeah, I mean you can just do the math, 25 times 10, 250, and then we click on set. So now everything is set to be able to record data. Now we want to where change the path where we want to save data. Okay. Now let's create a data folder under this trash. So let's say this sample others, and I'm copying the path here. So I copied path sample rf, and I should give a file name as well. Let's say abc sample.bin. So all the names should end with bin extension because the radar records a binary file. Okay. So now after being done, these things are being done. The first thing you need to do is to click on DCA 1000 ARM button. So this kind of gets the DCA ready for data capture. Okay. And after pressing this, you have around 10 seconds to click on the trigger frame. This trigger frame kind of starts transmitting signal, starts transmitting the like radar and records the data. If you do not press this trigger frame for a long time, then GCA arm is going to be cancelled and you need to press it again. Okay. So now I'll show you like once it starts transmitting, this yellow LED light should kind of blink very frequently. So I'll keep this close. So I'll click on GCA arm, ready, and then trigger. So now it's blinking. You see? So it should record data for 10 seconds. You see the frame start event start in 56 seconds and it ended at 06. So it records for data for 10 seconds. And we want to now see if our data is collected correctly. So we go into this RF sample. This ADC sample raw is the raw data that we have. You see its size is 250, 55. It's very large for a 10 seconds of data. So if you record for 30, 40 seconds, it would be 1 gigabyte. Okay. So we also have a log file here. This is kind of the output of your parameters. And this is the raw data log file. So these are kind of showing the number of drop packages, etc. Other things. We are not really dealing with these. You can immediately delete this CSV and text files, but this binary file is important. Okay. So this now we collect our data, then we can do whatever we want with this data. So now let's say you want to use 2 transmitters. Okay. So now I'll first show you TDM mode. Okay, and later DPM. So for TDM, since we have 3 transmitters, let's say we want to use all of them and we want to have 3 chirps, okay? So what we need to do, we need to define each chirp separately. So first chirp is going to be chirp 0, okay? Chirp 0. And it's going to use only transmitter 1, transmitter 0, sorry. Okay, now we set this. Okay, chirp 0 is set. Now we want to set chirp 1 with transmitter 1. Yeah, but you don't, we can do it later. We are not really doing the same configuration right now. You first need to configure the chirps. Okay. So now we are configuring the second chirp, which is chirp 1. Now it's going to use the elevation antenna. We click on set. This is also set. Make sure that there's no error here. And then we have the third chirp with TX2. Okay. Now we set this. Okay. So all three chirps are set. Now in our frame we will have three chirps. So it's going to go from 0 to 2. Okay. But we cannot have duty cycle of 200%. So we need to reduce our number of chirp loops to a reasonable interval. Maybe something like 100. No, 100, even 100 is not too much. 88. Yeah, for example, 88, 86, something like this. Yeah, for example. Yeah, now we set again. So now our radar is ready again. And we are collecting data with the same name. I cleared the folder, so it's empty. So now again we are going to collect data. VCA arm and then trigger. So it's collecting data. Yeah. So it started 33, should end with 43. Okay, it ended. And it's recorded the data as well without any problem. Okay. So this post-processing button is used to kind of like visualize data. You can click on this to see this screen that we have seen at the beginning. Okay, you can play with these visualizations if you wish, but we mostly don't use them that much. We do our own processing. So this is how TDM works. If you are not going to use, let's say, the elevation antenna, you are going to use only the azimuth antennas, transmitter 0 and transmitter 2. Then in that case, uh, we can make your first, we can make the chirp 1 is using TX2, okay? The chirp 0 is using TX0 and chirp 1 is going to use TX2. You can set this, and then start chirp and end chirp is going to be 0 to 1. Okay, then you can increase your number of chirp loops to 128 and set this and then collect data again. So this is how TVM works basically. Now we are going into DPM. DPM is slightly different. What you need to do, you can define both chirps as using the both antennas. Okay, chirp 0 and chirp 1 is going to use TX0 and TX2. Okay, in binary phase modulation, because let's say, what is it? Yeah, here they are using this antenna and this antenna. Okay, so basically it's going to look something like this, since we are not using the elevation, and it's going to use both antennas. If you look at the EPM here, it's using both antennas. Okay, both chirp 0 and chirp 2 are using both antennas, but the second chirp is going to have a phase difference. And now we set the both chirps are using both antennas. There's another tab here called DPM config here. So now here the first chirp is not going to have any phase. It's going to stay the same. Okay, but the second chirp index 1, this is going to have a phase difference in the second antenna or the first antenna, whatever you want. That's why we are adding this 1 value here. So this 1 means 180 degree difference. So this is adding phase difference to the second antenna. Okay, and then we click on set. It's set successfully, and then we go into the sensor config tab, and again we are using chirp 0 and 1. We have two chirps. Okay, and then again this number of chirp loops can stay the same. Everything else is the same. We click on set again, and then we click data again. It's recording. So this is basically how BPM works. It's very similar to TGAM. There's only slight difference. So now let's look at data. So you see we have another sample file. This one. This 256 megabytes.
How can I understand this file?
So you can basically understand it from its time. But what I usually do while collecting data, for each recording, I rename the data. For example, let's say I'm collecting data for walking activity. I call this walking, and let's say participant name, let's say subject 0. But for example, subject 0 underscore. I use underscores in the name because it's easier to decode afterwards. You can read all the data automatically by finding these underscores and then extract the subject ID or the class name and iteration number from that. And you can say iteration 0, for example. So this is, and in each recording, you change this iteration to 1, 2, 3, 4. You can change the activity from walking to sitting, whatever it is. And then these should kind of like save separate files. Let's record this. It's recording. Yeah, it's recorded. Yeah, this is the raw data we have. And all the files have this underscore row underscore 0 at the end automatically. And that's kind of all.
Thank you. Thank you so much.
Yeah, you're welcome. So this is all about the data collection. If you have questions, you can let me know. Later, you'll see the data processing part, hopefully. Thank you for listening.